Hey, what's up guys? Back again with another video in the C++ series. This episode we're going to be going over how to work with files in your C++ projects for data storage. So far, whenever you try and store data, you're going to use a variable or maybe an array, which is pretty much a variable. And that data is going to be saved in your memory, your random access memory, your RAM in your computer as the program is running. But once the program turns off, all of that will be deleted from the memory because it no longer needs it anymore. So that basically means that every time you start a new program, you're going to have to work with new data. You can't save data inside the memory and keep it there even if the program is off. So we need to find a way to basically save data even if the program is turned off, and then we can access that data at a later date next time we run the program, okay? And there's many uses for this. Maybe you're making a program that is a word processor like Microsoft Word, and you're going to need that program to be able to save the documents onto their computer so that all the stuff that they just type is not lost. Also maybe some video games. Maybe you're storing video game data somewhere and you need to put it on your computer so that next time you start up the video game you can retrieve all your characters' data, stuff like that. And so there's just many uses for this, and this is basically how most programs store data. You just store it on a file, obviously, right? Because that's how before CDs and stuff existed, they had RAM. Well, I mean, we still have RAM today, but that was the only way to store data, which was on the RAM. But then they came up with external sources of saving data, which was done with like note cards and like punching holes in note cards and stuff like that, I think at least. And then they came up with like CDs, floppy disks, stuff like that. But I don't know, I'm not an expert on it. But I'm just saying that we're going to be using files this episode to be storing data and then retrieving data. So let me show you an example here. There's two types of files that you have to be familiar with. You have first you have a text file, and then you have a binary file. So a binary file is basically just a regular file that is made up of binary code, zeros and ones. So for example, a image, right? We can't open an image in Notepad++ or just Notepad on our computer because it's just an image, right? We can't, read it. So if we try opening this up with Notepad++, we're obviously going to see a bunch of random stuff here because it can't read it. It doesn't know how to read it. It's just an image. But if we make a TXT file here, new text document, we can name this text file whatever you want, open it up, and we can type stuff inside of it, right? Okay, let's save this now real quick, close it, and now let's say that this is the first time you've ever seen this file before and you open it with Notepad++. It knows how to read this file because it's a text file. It's basically encoded as characters, not as binary code directly. So basically, your computer knows how to read it right out of the box. So this is the same with various other file types. The .txt extension basically just tells your computer how to read it, basically. It tells your computer that this is a text file, even though there's different extensions that work with this, text file thing I'm talking about. But yeah, you just have to know between text files and binary files. Binary files are stuff that you cannot read with your human eyeballs because it's binary. But with text files, it's specially made so that you can be able to access the file and read it for human reading and stuff like that. So anyway, also let's say that you save a number to this file. Obviously these are letters right here. If we save a number to this file, like 10, we just saved a number, but these are actually characters, not numbers. This is ASCII right here, or Unicode, which is made up of ASCII. Oops. So just know that these are characters at the end of the day. So what we have to do when we're accessing this file in the program is convert them back from characters into numbers, if we're trying to get the number at least, or maybe from characters to strings. Pretty much the same thing. But anyway, that's just a simple explanation of that. So let's go back into here and try and work with this. So to work with files, we need to do one thing, and that's to establish a file stream, which is basically a connection between the file and your program. And a stream, it's called a stream because it's a stream of data. The data flows between your program and the file, pretty simple. And there's basically two types of basic level streams. You have an input stream and then you have an output stream. We've already worked with streams before. Maybe you don't know that, but we actually have. And this would be the cout and the cin streams. These are console streams, basically, for your console. Let me just add this real quick. So this is the output stream here, the cout output stream. And this is a stream that is established with your console. And then also, like I said, we have the cin stream. We've worked with these before. You can check out my episode 12 to learn more about this. But yeah, so we've worked with this before, so it's not nothing new. But we have file streams now, which is basically two different file streams. We have input file stream and then we have output file stream, just like cout and cin. and we need to establish an object to work with those streams. Like we have cout, that's an object. We need a file object if we want to access and connect to a file. So before we work with these objects, we need to do this. We need to include fstream. So this is the fstream header file. And the reason we have iostream now, as you might realize, is because we're using cout and cin. That is why we have iostream here, input and output stream. But if we want to use files, we got to use fstream. Okay, so hopefully that fits together now. You understand why that is there. So let's say we want to make an output stream, so we can output data to a file and save that file. Okay, that's one of the most simple things you could do. So we need to establish a file output object, or a file output stream object. Okay, pretty simple. And this would be ofstream. That's the name of the object. It stands for output file stream. Okay, pretty simple. And we can give this any name, like a variable pretty much. I'm just going to call this output file. Okay, and then you put a semicolon on the end. And then now that we have created that object, what we can do is open the file, or what we need to do next is connect this object, this file stream object, to a file. We need to establish the stream, right? So to establish the stream with the object here, all we got to do is do output file.open, and now we just got to provide the name of the file that we want to connect to. So we got to provide a location for this file, because by default it doesn't really know where to put it, I don't think. So you could just type in any file name. You could say awesome.txt or awesome.dat. I think that stands for data, whatever you want to use. But let's say we want the file to appear right here inside of this project that we have here. And that means that we got to provide the location for this. So if we right click this and do show in Explorer, we can open up the file explorer here, and we just got to provide the location of the project, or the location on our system where this would be located. So just click this up here. You can copy the path and then go back here, paste the path like that. And then as you can see, the slashes are automatically converted to double slashes, because you have to use that whenever you're using this. And then now you just provide the name of the file after this, because this right here is a folder, like right here. This is the folder, so we're inside the folder now, and we got to name the file that we want to put inside that folder. So we're going to call this awesomefile.txt. Okay. So if we called this function here the open function, and it works after providing the file path and the file name, what it's going to do, if the file does not exist already, it's going to create the file right here, and that's good so that we can start putting data inside of it. But if it already exists, what it's going to do is delete the old file and then replace it with the new file, an empty file, so we can replace it with new data. So on this low level that we're operating right now here, we're not going to be able to edit any files, so it's basically going to only be able to override files. So later on we'll learn in some more advanced file manipulation and stuff like that, file output and input and output. But for now, we're just going to keep it simple by only allowing overriding files and then reading files with the input stream. But for now, we're working with output stream, so OF stream. So now that we can pretty much hope that this works correctly. And later on, I'll show you a way to check and see if it connected correctly. But we can pretty much just hope this works, right? So now that it has connected to the file stream, a stream has been established. So now we can write data to that file. Okay. So the way we could do that is just by pretty much the same thing we did with cout. You usually do cout. Angle bracket, blah, blah, blah. We do the same thing with output file. So if you want to write a string to the output file, we do output file, angle bracket, and then we can put a string inside of here. So we'll call this is a cool file, bro. And then we put a inline on the end of this if we want to. And now that should put this string inside of the file. Okay, that's pretty cool. And before we exit the program, what we should do is close the file. So output file.close. And the reason you don't actually have to do this, because when the program ends, it's basically going to close the file anyway. But you want to do this, you want to get into this habit, because sometimes in bigger programs, you may forget to close it, and it's going to be open, and you're not realizing it's open, but it's going to be open, and you just want to have it closed. And also, it's going to free up system resources if you don't have a bunch of files open, you know. So just do that. Get into the habit of closing files once you're done using them. And then if you want to use them again, you could just reopen the file at any time, okay? Anyway, so now that we're closing the file, we can see if this works. So let's run the program, and it should connect to this file here, create the file for us, and then put this data inside the file, save the file, and close the file. It should do all of that for us. Boom, as you can see here, we get the awesomefile.txt, which is perfect, exactly what we told it to create. So let's open it up in Notepad and see what it says. Awesome, it says, this is a cool file, bro. Awesome. That's exactly what we told it to put inside of the file. So we know it works. So let's test this even further. We could do output file, and let's put some more strings inside of here. So we'll say poopity boop, inline. Actually, let me show you what happens if we don't use inline. Pretty much the same thing happens is what we do when we don't use inline with cout. It's basically just going to put all of this on the same line within the file, okay? So let's demonstrate that. So what it did basically is as this is running, it's going to delete the old file, replace it with the new one, and then replace it with this new data here, right? And then let's open this up, and as you can see, this is cool file bro, poopity poop, all in one line because we didn't use inline. Okay, easy peasy. So we can even use numbers like I said. So if we do inline here, and let's make a variable. You can also use variables, of course. So let's make a variable called age, and age is equal to 56. Oops. And then now we could say output file, your age is age inline. So it should say this is cool file bro. Enter, this is your age is 56, enter. Okay, so let's run this and demonstrate that. But we can actually open this up inside of here. There we go. So this is cool file bro, poopity poop. It's redoing everything right now. Boom, now it automatically reloaded for us and it says this is cool file bro, your age is 56. So like I said before, this is a text file, so that means that even though we have a number here, this is really behind the scenes just characters, so 5 and then 6. So in a second when we use an input stream, this is going to be automatically converted from a character back into a integer, basically, okay? So we'll get some experience with that. But let's see if we can play around with this some more. Let's make like a loop or something like that. So play around with it. So we're going to loop this 500 times. And we're going to say cout, or not cout, output file. And then we're just going to output I inline. Okay, so let's run this. And what it should do is do 0 through 499 inside the file here and then save the file. Pretty simple. Should work. And there we go. That was pretty fast. So now we get 0 and we can scroll down all the way to 499. Easy peasy. And yeah, those are the different ways you could use a output stream. All you got to do is establish a OF stream, which stands for output file stream. Establish the object here, give it a name like we did, and then you got to use the open function here, provide a file path and a file name, and then it's going to establish the stream with that output file, and then you could write data to that file just like we do with a cout stream. And then after that, use the close function to close the file to free up system resources, and since we're done with it, just close it anyway, and then the program ends, obviously. So that's how you work with output streams. Very simple, or output file streams rather. So now let's get some practice working with input file streams. So that means that we can get data from a file, okay? So now we need to establish a input file stream object. So input f stream, so input file stream. And we give it a name here, we'll call it input file. So now we need to establish the input stream between the file object and then the actual file itself. So we're gonna do input file.open. Now we need to give the name or the path and the name of the file. So we could go to here, copy this, paste it here, -- awesome file.txt. So with that path and name, we should be able to connect to the file, establish a stream, and if that works, hopefully we can assume it works, we can then grab data from that stream. So what we have inside of here right now currently is a bunch of numbers. So let's try grabbing the first number from this file, 0, and put it into a variable. So integer number, and so normally we would do cin to get stuff from the console. So now let's do instead input file, angle bracket, number. And of course the angle bracket is pointed to the right. So what this means is that the data that we grab from here is flowing into this number variable right here, okay? And so now that we have that variable, what we want to do is verify that we got it correctly. So we could do something like number, and then just do number just like that, print it into the console just to verify. And finally we need to do .close the file stream so that we can just get some practice doing that, because you need to do that just to get used to it. Of course you don't have to, but like I said, you should. Anyway, so it's running now, so let's see if it's able to print 0 into the console, because 0 is the first number. And boom, we get number 0. Perfect. Alright, so now let's say we want to read the second number from this file here, like 1, right? So we already read 0, obviously, and we outputted 0 to the console after storing it inside this number variable here. So that means that after we read the first one, after we call this statement here, our read position within the file is going to be moved to here. So basically think of it like this. There's a cursor inside the file that is placed after you read one thing of input from the file. So let's say we read the first one, it's going to be moved from here whenever you open the file to here after you read the first thing of input. And then after you read the second thing of input, it's going to be placed from here to here, and here, the more you read, basically. So what I'm trying to say basically is that whenever you're reading input from a file, it's going to read it in order. You can't skip around, basically. So let's say you're going to read the first one, you have to read the second one next, you have to read the third one next. This is called sequential file access. So we're not going to be able to get into the random file access, which is our direct file access later on, or until later on. So just for now, we're going to stick to sequential file access, which means you have to read it in order from the beginning of the file to the end of the file, okay? So anyway, let's get some practice with this. So let's say we just read the first one, so let's say we want to read the second one. What we could do is make a new variable here called number2 and store the input of the second number within number2, or we can just basically reassign the number from here. Since we already outputted it, we could just reuse number and reassign it. So we could do input file angle bracket number. So basically the same exact thing we did here, right? So then we're going to output number again. Just like that. So it should output to the console 0 and then 1. And there we go, we get number colon space 0 and then number colon space 1. Perfect. So let's make this even more advanced. Let's try reading all of the numbers from the file till the end of the file is reached. And so let's loop through everything basically. So int number, we're going to make a for loop here. So for int I is equal to 0, I is less than 500, so basically 0 through 499. And then we want to do, every time it loops, we want to do input file, store that input into number, and then output number inline, back into the console. And then it's just going to loop again over and over and over, okay? So let's try that out. Boom, now we see that we have all of the numbers all the way from 0 to 499. Exactly what we wanted. Alright, and that's actually pretty much it for establishing input file streams and output file streams. All you got to do is create those two objects, and then you got to open the objects by using the open functions to establish the stream. But let's do something a little more advanced, okay? So let's make some more practice examples here. So let's say we want to make a program that allows the user to type input that they want to place into the output file, okay? So let's try this. So let's do, let's think. Cout how many names how many numbers, let's do numbers, do you want to save? Okay, and then we're going to do cin numbers int numbers. So we're going to ask the user how many numbers they want to save inside the file, so they're going to be allowed to enter that into the console. And so what we want to do is, we need an output stream here, so OF stream, output stream, or output file, I guess you could call it. And then we'll do output file dot open. And where do we want to put this file? Let's copy this. And you don't have to use that file location, obviously. By the way, you can put it on your desktop. You can put it anywhere. So let's say we want to put it on our desktop. We can do that. We just copy the path and then add it like we did before. But I'm gonna just keep it here. So we'll go to development, C++. Copy this, paste, string, paste, dash, and we're going to make a new file called saved numbers.dat. We'll try dat. I haven't used that one in a while. We'll try that out if it even is a thing. And so what we want to do now that we established that, we want to ask the user for the 5 things they want to store inside that file. And then we want to save each of those numbers inside the file, okay? So let's try that out. So we're making a for loop here, and we want to loop however many times they just told us to, ask for numbers, okay? So we use numbers. So what we want to do is ask for the numbers, and we'll say give me a number, like that. So cin We'll call this input. And this is going to be a double, so a double input. So now that we got the number from the user, what we're going to do is take that number and save it into this file. So output file, like that. Sorry if you hear my phone buzzing. Inputs, just like that. So that should save it for us, and then it's going to loop over and over and over, basically however many times they tell us to loop, and then it should save that amount of numbers into the console for us. And after that, we want to close the file, so output file.close. So now let's run this and see if it works. Oh, we forgot to put a thingies right there, so let's rerun this. So now it says, how many numbers do you want to save? I'm just going to say 5. And then so that means that it should ask us 5 times for a number. So we're going to say 25.6, 45, 67.8, or 3, 4.5, and then, I don't know, it does that sometimes. I think it's just IntelliJ being retarded, or C-line being retarded. So 12.3. So let's check our file now to see if it was able to save 5 numbers into the file. So we'll go back to here, save numbers.dat. So it's a data file, so we can open this up in Notepad. And now it says 25.6, 45, 67.3, 4.5, and 12.3. Perfect. So it's able to read those numbers that we entered successfully. Pretty cool. So that's just an example of to do something like that. But let's say we want to then let's make another program. Let's say we want to make a program that is able to read one file and then take that file data and then put it into a new file. So copy files basically. So let's try that out. That'd be kind of cool. So what we're going to ask the user is the name of the first file. So give me the name of file 1, like that. So cn file name 1. We're just going to make 2 strings here. String file name 1 and then file name 2. So that's going to ask for that. And then we want to ask them for give me the name of file 2. So cn file name 2. So now that we have those 2 files, we want to establish 2 different streams. So we're going to be grabbing the data from file name 1 from that file and then pasting all of that data into file name 2. Basically a transfer of data, copy and paste type thing. So first we're going to need a input stream for file 1 to grab the data from there. So we're going to make if stream. We're going to call this input file. And by the way, you don't have to end it right here and then start doing input file.open. You could actually just do this and then give the path right here, just like that. That's kind of another way you could do it. So let's give the, or we're just going to paste in file name 1. Oops, file name 1. That should work. Yeah, okay, that works. There we go. So now we could do that. So that's going to establish a input stream with file name 1, whatever that is. Actually, let's change this to path. Give me the path of file 2. Okay. You know what? Let's keep it as a name, but let's have the path as just this, to keep it simple. So we'll copy this, put it right there. So that's going to concatenate this string onto the end of this string here. I think we have to do plus actually. So plus, that's going to add it onto there hopefully. And yeah, that should work. But we need to add a / on the end of that. Anyway, so now we have the input file stream. So now let's do the output file stream. So OF stream, output file, and let's just copy this into here, and let's change this to 2. All right. So now that we have the input file stream and the output file stream established hopefully correctly, we should be able to, well, first we need to grab all of the data from file 1 and then put it into file 2. So you may be wondering, how do I know how much data is in file 1? How do I know how many times I need to loop, right? So there's one trick you could do, to do that. I don't even know what I just said, to do that. There is one trick you can use to do that. That makes sense. There we go. So while all we got to do is plug in file name or input file, angle bracket to grab the input, and then we want to put this into a variable real quick actually. So what are we grabbing? We're going to be grabbing, what do we want to grab? Strings, I guess. So string data. So string data is empty. It's not initialized. It's just empty. And then we're just going to put data just like that. So what this is going to do, this line alone, let's say we have it outside on here. this line alone, as you know by now, is just going to grab one string of input from the input file stream and then put it into data, right? Oh, right, it's an input stream, so we just want to change this to the other way. So the data goes from here to here. So yeah, it's just going to grab that data and then put it into here, right? Easy peasy. So if you actually take this statement and then put it inside of a condition like a while loop or an if statement or something like that, this statement right here returns a Boolean depending on whether this was able to read the data or not. So this will loop one time, read the condition, and it'll say true if it's able to grab the data and put it into the data variable here, but false if it's not able to grab the data and put it into the data variable here. Maybe if the file maybe if it's at the end of the file, it's not able to get any data anymore, that's when it'll return false, maybe, okay? Or if there's some other error. So basically what this is going to do by itself, what this is going to do by itself, if we can do this, is basically loop however many times it's able to successfully grab data from the file and put it into the data variable. So this is an easy way to loop through the entire file, just because this returns a Boolean depending on whether it's able to read the data or not, okay? So now that we have that data, we don't need to call input file angle bracket data again. This alone will take the data and store inside the data variable all at once while returning true or false. So all we got to do now is do out file and then output the data that we just stored inside of the data variable and then put it inside of the output file stream here. Data just like that. So that should do that for us. So now we could do input file dot close and then output file there we go, output file dot close. Yeah, should do all of that for us. So just to recap what happened here, what we did is we asked the user for the name of the first file, we asked the user for the name of the second file, and we added that file name onto the end of this path here so they don't have to specify the whole path. So by default this is going to be the path. And then after that it's going to basically loop through the entire input file, you know, whether there's something it can loop through. And then if it's successful, if it's able to grab one piece of data, it's going to take that data and then output it into the output file from the data variable. And it's just going to loop through that the entire time until it reaches the end of the input file. And then it's going to be done putting stuff into the output file. And once that loop is done, it's basically just going to close both of the files. So hopefully that makes sense. So let's run this. And well, first we actually need a file with input inside of it. So let's go into here, create a new file. And we'll call this data file.txt. Let's open that up. Put some stuff inside of here. So we need some strings here because this is going to be it's going to be grabbing strings, obviously. So we're going to say Mohammed is a poopy head. Yeah, you know it. And so let's save that now. So let's close this, and now let's run this and see if it works. Okay, so I just made a little mistake real quick. I accidentally, used the wrong path. I forgot to add this little folder on the end of it. So that now the name of the path should be correct. So it should be able to copy the data from file 1 to file 2. So now it says, give me the name of file 1. So I'm going to say, let's call it datafile.txt, and then give me the name of file 2. We'll call this new datafile.txt. And boom, now we get new datafile.txt, but it does not have anything inside of it, which is interesting. But this one does say datafile.txt.txt, so that could be the issue. So let's just rename this to .txt real quick, just to fix that. Boom. Where's that? Okay, yeah, so it has the data inside of it still. So let's try it one more time. Alright, so maybe it works now, and boom, we get Mohammed is a poopy head, yeah, you know it, all in one line. So let's analyze this a little bit. So it says data file, so we have datafile.txt right here, right? And each of these strings that we have here is separated by some sort of white space. So like a space, maybe an enter. So there's an enter separated between head and yeah, another enter between yeah and you, and then space between you and no, and the space between no and it. So basically, like from episode 12, we learned that whenever using the cin to get input, like cin data, it knows to stop getting input whenever it reaches a white space. So like, for example, if we do cin string for the first one, it's not going to stop at the end of the line. It's going to stop at Mohammed because we have one white space here. Oops. We have one white space right here, right? And so the same thing goes for input streams, input file streams. Whenever you grab one piece of input, maybe a string from this input stream here, it's only going to grab the first one until it reaches the white space right here. Okay, so and then it's going to place everything on one line, obviously, because we didn't use the inline thing right here like that. We could have if we wanted to, but yeah. Anyway, so let's say we're going to grab like maybe a full line, this whole line right here. We can try that out. We can just do what's it called? Well, first we need to do include string, and the reason we have to include the string header file right here is because we need that to use the getLine function. So the first thing we need for the getLine function is usually the cin object, but since we're not using that type of stream currently, we need to provide the input file stream object. So input file, and then we could do we need to provide the variable that we want to store the line in, right? So it's called data, not string. There we go. So what this is going to do basically is grab one line of input from input file and then store it into the string called data. Okay, hopefully that makes sense. Let's get rid of that. And then after that, let's output it just to test it. Data, just like that. There we go. Hopefully that works. Let's try it out. Boom, so we'll do data file.txt, new data file.txt, and it says Mohammed is a poopy head. So let's go back to data file.txt. And the reason it says Mohammed is a poopy head and not Mohammed is a poopy head, yeah, you know it, is because it's reading one. We're using the getLine function right here, right? So it's only going to get one line of input. So it knows when to stop whenever it reaches a enter. Whenever we press enter, that's when it knows to stop, basically, okay? Instead of like a space or a tab or something like that. Anyway, so hopefully that all fits together now. So also watch episode 12 if you haven't watched it yet. I redid the episode, so make sure you go back and watch that. I did it yesterday. So that's pretty much it. There's one more thing I want to show you though, is we showed you a second ago how to use the while loop to basically loop through the entire file until it's done. Because this statement here, like input file data, that statement right there will return a boolean telling you whether this was successful or not. So that's how we are allowed to loop through an entire file with a while loop. Or what you can do is do an if statement, and then all you got to provide is the object name here, so input file. And what this will do by itself is basically just return true or false depending on whether it was able to open the file or not. So let's say you don't know if this was successfully able to connect the stream or not. You can use this with input file or output file. Either one works. And if this is true, obviously this code inside of here will be executed, and you can move this inside of here. Because obviously you only want to close the file if it was able to open the file. And again, this tells you if the file was able to be opened. So don't forget that also. Also, we'll be going through some example programs on using all of this stuff we learned this episode, so you can get some practice using this. But that's pretty much it. That's how you use input file streams, output file streams. That's how you do all of that. All you got to do is, again, establish the file stream objects here with the path name and the file name itself. And then you could do use the angle brackets right here, like use these things to get data, and then send the data, however you want to do that. And then also you can use the close function to close the file streams once you're done. And that's pretty much it. If you have any questions about what I showed you today, you can ask in the comment section below, or you can join our Discord server. We have a Discord server with about 700 people, so you can ask questions there, get help, get some friends if you're lonely like Mohammed, or just do whatever you want, it's your choice. Also, all of the code for today's video is in the description below, so make sure you check it out and bookmark it for future use in case you forget how to use file input and file output streams. So yeah, make sure you do that. And that's pretty much it. So if you like this video, leave a like. If you want to see more, subscribe, and peace.